What is up, dudes? All right, so today we are going to, work with more functions, but this time involving e, and that is actually a number. Okay, and I'll show you what e is. You know how like pi is a Greek letter, but it represents a number? E is the same kind of thing. E is a letter that we use to represent 2.7. So let me just show you what e is. E is approximately 2.71828. So basically 2.71. Okay, that's all you really need to know. And it is called the natural base. Okay, it's called the natural base. Okay, and this is where it comes from. I'm not going to go into the history, really. I probably don't know enough about it anyway, but this is where it does come from. It comes from this, 1 plus 1 over n to the power of n. Okay, and basically, if you plug in 1 right here, okay, well, you can't plug, can you see a number that you can't plug in? Okay, you cannot plug in 0 because 1 over 0 is undefined. Okay, you start with 1. Plug in a 1 here, so you get 1 plus 1, right? 1 over 1 is 1, so that's 2 to the power of 1, and that's just 2. Okay, so, all right, remember, this e is going to be 2.7. So now plug in 2, so 1 plus a half, that's 1.5 to the power of 2. That gets you a little bigger. Plug in a 3, then you get 1 plus 1/3, raised to the power of 3, gets you a little bigger, and basically, eventually, it kind of starts to really get closer and closer and closer to this number e right here. So if you're curious about it, go ahead and plug in numbers in your calculator. I'm not going to make you do that, unless your homework asks you to. All right, let's see. So this approaches e, or 2.7, approaches e as n goes to infinity. Okay, or basically as n gets bigger and bigger and bigger and bigger and bigger. Okay, all right, so let's do part A. So that's just some background, nothing more you really need to know. Okay, let's simplify natural base expressions. And what I mean by that is simply something like this. E to the power of 2 times e to the power of 5. Okay? And in this case, e is just like x, okay? So it's just going to be, what do you do with the powers there? You just add them. So e to the 2 plus 5, that's e to the 7th power. Okay? That's very straightforward. Same thing with doing something like this. Check it out. If I have something like 12e to the 4th over 3e cubed, okay, this is just like any other variable, okay? Simplify the 12 over 3, that turns into a 4, right? Okay, and then cross this guy off, right, and put a negative 3 up here. That's e to the 4 minus 3 is just e to the first power, so e to the first power is just e. So we have 4 times e. Okay, that's very straightforward. Okay, again, if you're struggling with that, please come into office hours. This is basic, okay? All right, here we go. Let's try something like this. We have 5e to the negative 3x to the power of 2. Now, this might look a little intimidating, but remember, if I give you something like this, remember, say I have 2x squared times y or something, and I raise it to the power of 5, okay? Remember, all you do is distribute that power to all the powers inside, okay? So you get 2 to the power of 5, x to the power of 2 times 5, which is 10, okay? And then y to the power of, well, it's a 1 times 5, so 5, okay? All right, so that's the idea that we're going for right here. So we'll distribute that power. So it's going to be 5 to the power of 2. and then e to the negative 3x times 2, right? So that's 5 to the power of 2 times e to the negative 6x, okay? Again, just very straightforward, okay? And now 5 squared is 25 over, remember, a negative power drops that guy to the denominator, so it's going to be e to the positive 6x. All right? Here, you try one. Try this one real quick. All right? Try something like this. How about this? 10 times e to the negative 4x, 10 times e to the negative 4x raised to the power of 3. Okay? All right, so here we go. We get 10 to the third power. We get e to the negative 12x. All right, and that's going to drop down. So we have in the numerator 10 to the third power, that's 1,000, or it's a 1 with 3 zeros. And then in the denominator, we have e to the 12x. Okay. And let's see if you guys can do this example real quick. How about the square root of 25e times e to the power of 10x? Okay, see if you could do that. All right, here we go. This is the square root of 25, or you could think of it like this. Well, the square root of 25, isn't that just 5? Okay, if you want, check it out. This is the power of 1/2, so you could put 25 to the power of 1/2, right? And then times e to the 10x times 1/2, okay? Remember, because you could write this as, you could write it like this, how that is, only instead of a power of 3, it's the power of 1/2. So you're just distributing the 1/2 to everything, okay? And so now you get 25 to the power of 1/2, that's the square root of 25, which is just 5. And then 1/2 times 10 is 5, so we get e to the power of 5x. All right. All right, so let's do part B. Let's evaluate natural base expressions. All right, natural base expressions. All right, and we're going to use a calculator. Use a calculator. All right, and we'll just do something like this. We'll do 2 quick things real quick. How about this? E to the 4th, okay? And how about e to the negative 0.09, okay? All right, so check it out. Turn on your calculator. Let me get out of here. All right, so let's go e to the 4th. So to find the e button, it's right here. See the ln? That stands for like natural log. Right above it, we have e to the x. So just go ahead and hit second and hit that. There, you got it. And it's to the 4th, so put 4, now push enter. It's 54.6 or 54.59. Okay, straightforward. Do this one. All right, let's try it. Here we go. E to the power of negative 0.09. Enter. 0.91. Okay, so 0.91. Now I want to show you something really quick before we move on to the next part. Look at this. E to the power of 4, right? Notice what kind of a number I have. I have a number that's greater than 1. Huh. Interesting. Okay. Look at this guy right here. I have e to a negative power, right? Look what it turned into. That is a number that is in between 0 and 1. Huh. Just keep those in mind. Okay? Here we go. Let's do part C. Growth or decay? All right, let's do this. Example. Y equals 3 times e to the 0.25x. Growth or decay? Well, what is B? First of all, what is B? B is 2 point something, right? So 2.71, okay? So that tells us it's growth. No matter what this exponent is, if you multiply that, raise it to that power, okay, you got growth. Okay? But check this out. example, okay, we have y equals e to the negative 0.75, okay, times, how about x minus 2 and then plus 1. All right, what do you think that's going to be? Okay, notice that negative. That's going to take this guy and bring it to the denominator, okay, which is going to give us a fraction, which is going to put our b value, okay. Here, let's just do this really quick. Watch this. E to the power of negative 0.75. Watch what happens. What do you get? You get 0.47. Okay, so b equals 0.47. That is, my friends, decay. Okay. All right, so when b is greater than 1, cool, and that's because that's a positive exponent right there. B is going to be in between 1 and 0 when we have a negative exponent. All right, so let's graph one of them. I have just enough time to graph one, okay? Let's graph this one, okay? So let's write this down. Graph, here we go, example. Y equals e to the negative 0.75 times x minus 2 and then plus 1. And let's, just for fun, let's make this negative, okay? Just put a negative right there, just for fun. All right, here we go. Let's get our t-chart going. By the way, what's the shift? What is h, what is k? All right. Does it shift to the right or the left? Does it shift up or down? Okay. All right, it shifts to the right 2 places. It shifts up once. So let me go to y equals. Let me clear this. And I'm going to put negative e, okay, to the power of, sorry. Let me back out of there, clear that. It was already to the power of, so negative e, all right, it's already raised to the power, so negative 0.75, okay, and then I got times x minus 2, so x minus 2, and then I'm going to get out of there and put plus 1. All right, and let's get our table. All right, now remember, this shifted 2 places to the right, okay? So remember how if I just set up my normal t-chart, I put -2, -1, 0, 1, 2. All right, but this shifted 2 places to the right. So look, if I would have started with -2, it gives me -19. That's too big. I don't want to graph that. Even this one, -1, that's too big, okay? But let's just start with 0, okay? So I'm going to go 0, 1, 2, 3, 4. Okay, so 0 is -3.4. Okay, 1 is, let's see, -1.1. 2 is 0. 3 is 0.5. 4 is 0.7. Okay, all right. And let's go ahead and set this up. I know I should have been using graph paper, but whatever. Okay, here we go. It'll be fine on this, okay? First of all, is this growth, decay? Okay, we know it's decay because of this negative right there, okay? I also know it's going to be flipped, okay? So let's get my asymptote. Where's my asymptote? It's on plus 1. So here it is right here. So 1, it's y equals 1. All right, and let's plot this. 0, -3.4. So 1, 2, 3.4 is right there, okay? 1 is 1, -1.1. So -1.1 is right there. 2, 0. Okay, 3, 0.5. 3, 4, 0.7. It's right there, and here is my graph. And I know we talked about it last time, that's decay, because as you read it from left to right, look at the space between this and the asymptote. It's getting smaller as we go to the right, okay? All right, guys, so that is it. Hopefully that's helpful. If not, come see me in office hours or after Zoom, and I'll talk to you soon. Peace.